Hi, this is Olajide from CTF Security and welcome to day 6 of TryAcme Advent of Cyber 2023. In today's video, we will be exploiting a simple buffer overflow and we have the following objectives in mind. First, we want to be able to understand how specific languages may not handle memory safely. Secondly, we want to be able to understand how variables might overflow into adjacent memory, thereby corrupting that memory. And lastly, we want to be able to exploit a simple buffer overflow to directly change memories we are not supposed to access. So without further ado, let's get started. Alright, welcome to today's task. As you can see, the tagline for today is Memories of Christmas Past, and we have our Start Machine button right here. So I'm going to click on that button and wait for our machine to fully boot. And this is going to take about 1 minute. So while that is coming up, let's take a look at our storyline. So throughout the merger, we have detected some worrying coding practices from the South Pole elves. To ensure their code is up to our standard, some firstlings from the South Pole will undergo a quick training session about memory corruption vulnerabilities. All courtesy of the B team. Welcome to the training. Now we have our learning objective, which I've clearly stated in the video introduction, so I'm going to be moving away from that. And we have, be sure to hit the Start Machine button at the top right corner of the task. All you need for this challenge is available in the deployable machine. Once the machine has started, you can access the game at this link right here. So the link is going to be updated as far as your machine has fully booted. So I'm going to right click, I'm going to copy, and I'm going to open this in a new tab. So let's go back and see what we have. If you receive an error, which is 502 error, please give the machine a couple of minutes to boot and then refresh the page. So let's just go into the game properly because we're going to be working with a game here. In this game, you will play as cat or mouse. That is going to be our character name. Your objective is to save Christmas by buying the star for your Christmas tree from Van Frosty. In addition to the star, you can buy as many ornaments as you can carry to decorate your tree. To gain money to buy things, you can use the computer to do online freelancing programming jobs. You can also speak to Van Holly to change your name for a fee of 1 coin per character. It says that this is totally not a scam. It will actually start calling you by your new name. It is, after all, into identity management. I see. So let's see what all this is all about. So this is the game interface. You just need to press the space bar and you see the game controls. We have the arrow keys in order to navigate through the game screen. We also have the space bar to interact or speak with characters within the game. We have the tab key to open the debug panel and the backspace to reset our inventory. So I'm going to press the space key and we have our game. So what I'm going to do now is to just reduce the screen size so we can see all the text. Okay, so this is our character. This is us. And we have some information here. To finish the game, all you need to do is to get a star to put upon your Christmas tree. And this is the Christmas tree here. After you get the star, just interact with the Christmas tree and that's it. You are free to buy as many additional ornaments as you can carry to customize your tree. Okay, so let's just move around. You can move around. You can see the PC where we can perform our freelancing programming tasks in order to gain coins. And this is different. This is one character in the game. Let's see who this is. Oh, this is Van Holly. And the instruction says you can speak to Van Holly to change our name. Okay, so this is the character that changes name within the game. Interesting. So let's try this. We have just 1 coin. howdy cat or mouse, which is the name we are playing the game with right now. I can change your name for 1 coin per character. Sound like fun. Let's do it. So let's change our name to C, and I'm going to hit the enter key. There you go, enjoy your new name. So our name is now C. You can see it right here. Thanks. How do you even change names anyway? I work in the identity management, you know. Oh, that explains it. Now what we're going to do is to take a look at another character. This should be Fan Frosty. Welcome to the store. Is there anything you want to buy? Okay. Okay, so Van Frosty is the inventory guy, and these are the items in the inventory. We have the red ball for $5, green ball for $10, mushroom for $16, and we have some sold out item also, and we have our star here. So now this is our focus here. If we're able to buy this star and put on our Christmas tree, then the game is over. So let's see what we can do. I'll just go away from here. There's no item. Of course, we didn't select any item to buy because there's no money yet. Let's see the description for the game. Now, the first scenario for this game is somebody made an observation within the game, and this is Van Jolly. So Van Jolly approaches Mark Honeybell and say that they have been observing some weird behavior while playing the game, and they think the ghost of Christmas past is haunting it. Mark Honeybell asks them to reproduce what they saw. Van Jolly boots up the game and does the following, which you are free to replicate too. So what Van Jolly did was he actually used the computer until he got 13 coin. Then he asked Van Holly to change his name to Scrooge Rocks. Scrooge Rocks is having exclamation mark at the end. And suddenly you have 33 coin out of nowhere. So this looks like a bug to me, because the only way you should be able to have coin is through the freelance programming job. But let's go back and try to replicate this and see what that is all about. Now let's go, let's move to our PC and let's do some tasks to get about 13 coin. So you can just keep pressing your space bar, you just hold it down, and this is going to start incrementing the gold coin. $11, $12, $13. Cool. So we have 13 coins. So let's go ahead and change our name. So you see our new name is now C. I can change your name for 1 coin per character. Sound like fun? Let's do it. So we are using Scrooge Rocks, exclamation, and we send. Oh, and we got 33 characters. So this explains what Van Jolly is trying to say. Now let's see what is happening here. Van Jolly explained further, and he says, when you change your name to anything large enough, the game goes nuts. Sometimes you will get random item in your inventory, or your coin just disappears. Even the dialogue can stop working and show random gibberish. This must surely be a work of magic. Mark Honeybell doesn't look convinced. After some thinking, she seems to know what the problem is all about. But in order to understand what the problem is, we'll need a debug panel as suggested by Mark Honeybell. And luckily for us, the application or the game has the debug panel built into it. So to access the debug panel, we're just going to use a tab key, and this is going to show us the debug panel. Now this panel has 2 views, which is the ASCII view and the X view. We are currently viewing the ASCII view now. Now let's take a look at what happened. We have some variables in here. We have the player name variable, we have the coin, we have the shopkeeper name, we have the namer name, and we have the inventory items. And we have each variable address space assigned to them. For example, the player name has total number of 12 bytes, the coin has total number of 4, the shopkeeper name has 12, the namer name has 12 also. We have additional 4 extra here, and we have inventory item which have about 16 address space. Now what you notice is that the name which we just used, let's scroll up a little bit, Scrooge Rocks. Okay, cool. The Scrooge Rock here is 13 characters, and if you go to the debugging mode, so what happened here is that the Scrooge Rock, which is the name we updated our name to, get updated in the player name. So because it is 13 characters, what happened is since the player name can only support 12 character and the name we updated to is 13 character, so it will take the first 12 character inside the player name and the last character will overflow to the next address space, which is the coin we are seeing here, so which is exclamation mark. So to understand this better, if we convert this exclamation mark as a text and we convert it to hexadecimal, or we convert it to a decimal value, we'll get back 33. So let's quickly do that. So I want to convert from text to decimal, and let's convert exclamation, and I click convert. Oh, I beg your pardon. That was a mistake. I was supposed to convert it to X first, and then let's put in the exclamation and convert. So we have a value of 21. Now, if you take the 21 and you convert from X to decimal, you see that we have 33, which explains why we have 33. So this looks like the application is vulnerable to buffer overflow. So let's continue and see what else we can do. So we've just succeeded in explaining why we have 33 anytime we change our name to Scrooge Rocks. So this is explaining the debug mode. Okay, good. So to prove the point, Mark Onibel proposed replicating the same experiment, but this time we'll get 13 coin and we'll change our name to this. So we can easily predict this based on what we just did earlier. The first 12 bytes is going to go into the player name address space, while the X is going to move into the coin. Then we have to convert the X to decimal to get what coin we're going to be having. So let's just refresh this game and perform that action again. So quickly, we're going to move to our freelancing job and let's get 13 coin. Okay, cool. So if we go to Van Holly and we change our name to, let's see, AAAABBBBCCCX. Okay, so let's go 2 3 4 1 2 3 4 1 2 3 4 X, and we press enter. You see that we're having 120 coin, and if we go to the debug panel, you can see that the first 12 bytes is being filled up with our updated name and the last character overflow into the coin address space, and this is the reason why we're having 120. And just like we did before, if you convert from text to X and we have X here, we convert, we're having 78. Now if we copy 78 out and we switch from X to decimal and we paste our 78 and convert, you see that we have 120. So this explains the buffer overflow vulnerability that we have in this game. So let's scroll down and see what next. Oh, is anything wrong with my machine? What's happening? Let's just quickly check that. Okay. Let me quickly make sure I'm still connected. So I had a network issue and I had to restart my machine. You can see the countdown is going on. So let's see what next we can do. If we scroll down, I believe we've gone through this part. So this is the explanation of the scenario we just went through. The X at the end of our new name split over the coin variable. The ASCII hexadecimal value of X is 78, which is what we had here. And so the coin value was changed to 78 or 120 in its decimal representation. As you can see, Mark Onibel prediction were correct. The game doesn't check if the player name variable has enough space to store the game. Instead, it keeps writing to its adjacent memory. Okay, so I'll just fire up the game once more because I had to restart the machine. So let's get the link. Copy, and I'm going to launch it. Okay, that didn't copy. Copy link. Okay, so let's scroll through. So as you can see, Mark Onibel prediction were correct, which is what we just saw. Buffer overflow occur in some programming language, mostly C and C++, where variable boundaries aren't strict. If programmers don't check the boundaries themselves, it's possible to abuse a variable to read or write memory beyond the space initially reserved for it. Just like in the case of our game is written in C++, which explains the reason why we are probably vulnerable to the vulnerability. So let's scroll down and see more details. So we have another scenario. By now, the Frostlings look baffled. It never occurred to them that they should check the size of a variable before writing to it. Van Twinkle has another question when the game started. The main character name was cat or mouse, which only used 10 characters, which is what we're seeing here. How does the game know the length of string if no boundary check are performed on the variable? Now, to explain this, we're going to recreate another scenario. We're going to restart the game, which I've done already. We're going to get 3 coins and we're going to change the name to health. So let's quickly do that. I have to adjust the screen size. Okay. So let's go get some coin, just 3 coin. And let's go change our name from Van Holly. So we are changing our name to Elf. And when we hit the enter key and go into debug mode, now you see what happened here. We have our player name and the address space. And from this address space here, we have the ELF into the first 3 bytes of the address space. And we have a null byte appended to the end of the string. So whenever the program is reading this variable and it encounters a null byte, it terminates that particular address space and just move to the next. So that is why we still have leftovers from the previous name that we have, which is the cat or mouse, still present within the address space. Let's go back to the game. So this is just the exact scenario we have here. So explaining the null character. The null character represented in our game by red 0 is also concatenated at the end of the string. A null character is simply a byte with the value of 0, which can be seen by changing the debug panel to X mode or to ASCII mode. So to better explain all of this, Mark Onibel proposed a second experiment on strings. Now this time around, we are expected to have 16 coins and rename our character to this. Now from the understanding we have about this game previously, we know that the name can only accept 12 characters. So that explains that the AAA, BBB and CCC will fill in the address space. Then the DDDD will move into the coin address space here. But there will be an issue. Let's just try this out and we're going to see how that will affect the game. So quickly, let's go to our PC once more and let's do some job. Let's go to our PC. So we need 16 coin. We're working our ass off. Okay, so we have 16 coin and our PC is broken. So we can only have access to 16 coin through the freelance job. Now let's go to Van Holly. And let's change our name to 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. And when we hit the enter key, you see what happened here. We have our player name filled in with A, B, C, and the D overflow into the coin's address space. And what happened here is because the address space for the player name needs to be terminated by a null byte. So the null byte encroaches into the shopkeeper's name, and this will render the shopkeeper name empty because this is a null character. Now, if we try to go and see the shopkeeper, let's quickly do that, which is the Van Frosty. You see that Van Frosty name is gone because of the presence of this null byte character. So that is basically what we're trying to explain here. While doing this experiment, Van Twinkle mistyped the name during the previous experiment and ended up with AAA, BBB, CCC, DEFG. Then they noticed that they had this value of coins in the upper right corner shown as follow in the debug panel. Out of curiosity, they used an online tool that converts hexadecimal to decimal number to check if the hexadecimal number from the debug panel match their account. To their surprise, the number were different. Okay, so let's try and see what actually happened here. I'm going to refresh the screen and we need to perform our task again. So let's quickly do that. So we need about 16 coin in order to replicate the experiment of Mark Twinkle. Okay, great. So we have that. So let's go to Van Holly and we're going to change our name to A, B, 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 which is 4, 1, 2, 3, 4, D, E, F, G. And when we hit the enter key, you notice that we have this value. Now, when we convert the value using an online tool, we discovered that the X number does not tally with the decimal number we have on our coin. So let's try to confirm that. Now, let's open the debug panel. If we switch to the X mode by using the tab key again, we see that we have a value for the coin to be 44, 45, 46, 47. And if we take these four values and we convert using X to decimal, which is 44, 45, 46, and 47. If I hit the convert, you see that we have a value that does not match what we have as our current gold value. So let's see what this problem is. So Mark Honeybell explained the integers in C++ are stored in a very particular way in the memory. First, integers have a fixed memory space of 4 bytes as seen in the debug panel, which is what we are seeing here, 1, 2, 3, 4. Secondly, an integer byte are stored in reverse order in most desktop. This is known as the little endian byte order. So let's go back and see if this is actually correct. So instead of starting from 44, this time around we'll be starting from 47, which is 47, 46, 45, 44. And when we compare this value with the number we have on our gold coin, you see that this number matches. So let's go back and see what we've got next. So winning the game, Mark Honeybell is about to wrap up the lesson and call it a day. But first, she explained how an attacker could now overwrite any value to the coin variable and have enough to buy the star and finish the game. On hearing this, Mark Greedy starts laughing and tells Mark Honeybell they rigged the game so nobody could win. Mark Honeybell is more than welcome to try to purchase the star, Mark Greedy says. Mark Honeybell does some quick calculations and concludes she should be able to get enough coins. She looks at you and asks you to show how the vulnerability can be exploited. You notice that she looks little doubtful, but still, it's now up to you to win the game. Can you get a star in your inventory and prove Mark Greedy wrong? So that is what we are going to be doing basically. And the star is going to cost us about $1,000 gold coin, I guess. So let's move to our game. You notice that we have enough coin already to purchase this game from our last experiment. And if we move to Van Frosty, which is the inventory guy, and when we try to purchase a star, and you can see that each of these items has an ID which we are going to use to purchase them. So the ID for the star is D, and when I type the D, it gets selected, and when you hit the enter key, you get a message and it says, hey, you are not supposed to have that kind of money. I earn each coin, that is we talking now, I earn each coin fair and square. Now give me my star. The game is supposed to be unwinnable, you know. Here, I'll cut you a deal. I'll give you a much cooler item for the same price. So we're giving this particular item. I don't know what this item is. And you notice that this item gets updated in our inventory. You can see it. This is 31. This is 65, which is the equivalent to this. And this is the equivalent to this. Okay. So let's go back to the inventory. Let's go back to the inventory. If the ID of the inventory is letter D, and if we go to converting from text to, let's convert to X, what is the equivalent of D, lowercase d? So we need 64 to be appended to one of these inventory in order for us to get our star. Now, if you want to confirm this, you see that this is ID 1. And if you go to 1, if you press the 1 here and you convert this from text, you convert it to hexadecimal, you see that we got 31, which is equivalent to what we have here. You can also convert this icon, but the icon seems not to be listed here, but it's 65. So we might know what the ID is if we do some little conversion. So we need the D to be present. Now we could do some little calculation if you want to purchase all the item we have here. So what I'm going to do is, let's bring my text editor. This is going to just take a few seconds. All right, so we need, can I just make it smaller? Basically, we need 1, we need 2, ID number 2, we need, what ID is this? Let's remove the tab key. This is 3, 4, 5, 6, 7, 8, 9, then B, C, D. So let's solve this now. Let's go to our game, and if we go to Van Holly, which is our identity manager, let's see what we can do. What if I pick a name that overflow the player name, overflow the coin, overflow the shopkeeper name, overflow the namer name, including the inventories? I believe that should work, right? So let's see what we're going to do. First of all, let's try to buy something different. Before we do that, let me just let's do something different. Let's go to Van Frosty first. I'll just buy something different. Let's buy Maskidi, which is ID 5, and press the enter key. Cool. So you can see that we have 3 items now. And you notice that on our inventory, we have the 3 first address space updated. So this is the value for the first item, this is the value for the second item, and this is the value for the third item. So meaning that if we know the value for the star item, we can update the value in order to purchase it. So let's go again to the inventory once more. So we know that D is the ID for the star. Okay, interesting. So let's go ahead. Let's go ahead to Van Holly to win the game. So we're going to pick a name. So this time around, let's pick for the first 4 characters. 1, 2, 3, 4, which is this. I'll just fill in the old player name with A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this will fill the whole player name address space. So we need to fill the coin also. Let's just use, for the coin, let's use D for the coin. So 1, 2, 3, 4, 5, 6. Okay, I think it's 4. So let's remove that. 1, 2, 3, 4. Cool. So we'll fill the coin. Now we need to fill the shopkeeper's name. We can decide to use the name that we have before. The name of the shopkeeper is Van Holy. Okay, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. We're supposed to have 12. So let's add 3 more, which is B, B, B. Okay, cool. So for the next one, we have namer name, okay, which is the Van Holly's name. So let's append Van. The other one is supposed to be Van Frosty. I just mix it, but it's still fine. So let's say Van Holly again, and I append how many? Let's see, 1, 2, 3, which will fill the namespace that we have here. Then we have 1, 2, 3, 4 extra space. Let's just fill that with A, which is going to fill this. Now we are left with the inventory. So what we can do, since we know that the ID for the star is D, I can just fill the whole of the inventory with the letter D. Make sure it's lowercase. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'll hit the enter key. And you notice that we've successfully purchased stars. So I think I mixed one of the address space. That is why we're having this here. But we've successfully purchased about 15 stars here, meaning that our attack is successful. So let's just go ahead and win the game. Let me move to the ASCII mode. So you can see that I want to see where the issue is from while this is here. So we have AAA as our name, DDD as the coin name, which is equivalent to this, shopkeeper Van Holly, good. Then we have name, which is the Van Holly also. Okay, so from the, I think the issue lies here. The first value is supposed to be D, but I represented it with A. That was why we have this item here. So nevertheless, let's just go ahead and win our game. So we're going to move to our Christmas tree, and we're going to interact with the Christmas tree. So you can see we've successfully won our game, and when we hit the space bar, you got the star. Thanks for getting me ready for Christmas. Here is your flag. So we're going to grab our flag. It's impossible to copy the flag here, so we're just going to use THM Mark Honeybell is the real star. So let's go and fill that inside the question for the challenge. So we have THM Mark Honeybell. Did I spell that correctly? Mark, okay, lowercase. Mark Honeybell is the real star. So I'm change this to lowercase. Underscore is the real star. So close it. We're going to submit, which is correct. And we have another question here. It says, if the coin variable had the in-memory value in the image below, how many coin would you have in the game? Not forgetting what we learned previously regarding how data are being saved. I think it's called Little Endian something. Okay, yeah, it's called the Little Endian byte order. So if we want to use that to solve this question here, we have 4F, 50, 53, and we want to know what value this will be equivalent to. So let's go ahead and convert that. So remember, we're supposed to put it in a reverse order, which will start from 53. The next value is 50, 4F, 4F. And if we convert this, you see this is the value we have. I'm just going to copy, and we're going to paste in here and see if that's correct. Okay, so that was correct. And then the last question, we have only explored the surface of buffer overflow in this task. Buffer overflow are in basis of many public exploits and can even be used to gain complete control of a machine. If you want to explore this subject more in depth, feel free to check buffer overflow room. I'm just going to click complete, and let's scroll down. Vanjoli still thinks the ghost of Christmas past is in the game. She says she has seen it with her own eyes. She thinks the ghost is hiding in a glitch. Whatever that means, what could she have seen? So that marks the end of this video. If you've learned one or two things from this video, please make sure you like, subscribe, and share. And I'll see you in the next video.